Thank you so much for having me. Thank you, Doctor's Data, for being there for us for the last, what is it, 50 years? I don't know, very long time. This company's been supporting all of us. Okay, so that's about me. Oh, and we have a special thing for you guys. If you want to scan that QR code, you get half off our Doctor's Data Masterclass on their GI 360 test. So it's all GI oriented material. And if you're interested in GI testing, it's one of the best tests on the market, and it solely suggests that. So check it out if you're interested. All right, but today we're going to talk about toxins. And so there's, I think the main point I wanted to prove today and just instill in you all is that you can't look at a patient and decide if you should test them for heavy metals. You just have to screen every new patient at any age, any condition, any problem they're complaining about, and see what their toxic burden of heavy metals is like. It's a fundamental thing that we have to do. The environment now is so toxic, and I just read this yesterday about the amount of mercury they're using to do gold mining in the Amazon. They use like a kilo of mercury for every kilo of gold they extract. The numbers are just so astronomical, and that all gets into the water supply. Obviously, it gets into ground, it gets converted into methyl mercury, and it gets into our bodies. Burning coal, gold mining, wherever this stuff is coming from, spewing lead in gasoline, which is something that was popular when I grew up in the 1970s. Every car used leaded gasoline. That lead is still in the environment. Arsenic on play structures. They put, they coated, the wood, that green looking wood that when you were a kid, you go, oh, it's a play on this play structure. That's arsenic. And they didn't ban arsenic in children's playgrounds until like I think it was 2002 or something like that. So if you're my age, you for sure played on a playground that was coated in arsenic. And they've even studied this. They measured this, like how much arsenic ends up on the kids' hands if they play on those playgrounds. A lot. So we're all saturated with this stuff. It's just the way that it is now. And then some people add to that burden of exposure. Like, I mean, there's not a lot of 5-year-olds that are thinking, oh, I'm going to go play an extra hour to get more arsenic, right? But it just happens to them. But then there's a lot of stuff we do intentionally to increase our toxic burden, which is like you could say alcohol, perhaps, and any kind of recreational drugs that people are doing. And if they're not keeping their house clean in terms of products that they're using. So the body burden that we have from heavy metal exposure, just from the environment being so screwed up at this point, coupled with the lifestyle things that happen to people. And then you layer on top of that the big problem, which is the genes. How good are you genetically at clearing all this stuff out? And the people that aren't very good at it, between the lifestyle generated toxins and the general things in the background in the environment, are sick and have problems. And the people that have really bad genetic issues, you're going to find in your practice because they're going to come in, they're going to have some cognitive problem, or it's going to be pretty obvious that they're toxic. But as I mentioned a minute ago, we're all exposed to these environmental toxins all the time. And so you have to know for every new patient what their total heavy metal burden is like. And at some point in the program, have a strategy for removing that heavy metal. It's not just for people that are super sick. You have to do this for everybody. Now, the super sick people tend to have genetic defects in whatever enzyme system, COMT, COMT, or MTHFR, whatever it may be. And those people are more obvious to find because they have a lot more problems, but we got to screen everybody for this. So I thought I'd start off because we don't have that much time, and I put a lot of slides together for you guys, and probably 2/3 of these slides I'm going to skip over because they're reference slides for you to look at later. You're welcome. Okay, so 2/3 of these slides are reference slides for you to look at later. We're not skipping over them on purpose in a bad way. I just wanted them, in this deck so you guys have them so you can study this stuff later on if you're interested in this subject. And we have tons of classes on all these subjects as well if you want to check out the Kalish Institute. In addition to the GI thing that we're doing with Doctor's Data, we have a lot of other courses related to this, okay? So one toxin, because we don't have time to go through all the 1,000 of them, mercury. But the thing that's interesting about this slide is you could take mercury out and put arsenic there, take mercury out, put lead there. You could probably get away with taking mercury out and putting toluene, benzene, or BPA there. So environmental toxins like mercury cause inflammation and oxidative stress in the body, period. They damage the mitochondria. And if you're looking for a way to shorten the human lifespan and to lead to chronic degenerative diseases like neurodegeneration, Alzheimer's, Parkinson's, mitochondrial and metabolic degeneration, diabetes and obesity, degeneration and damage of your DNA, that's kind of what we call cancer. And most importantly, I save the most important one for last. What's the most important tissue in the human body that if it gets inflamed and oxidized, kills you? Does anybody know? That's a question. What's the most important tissue in the human body? What kills most people? Atherosclerosis and cardiovascular disease. So heavy metals like mercury, lead, arsenic, cadmium, aluminum, all these things, they cause inflammation and oxidative stress in the body. That means in your blood vessels too. So these problems, environmental toxin issues, are responsible for a lot of the metabolic disruption that we see, a lot of the neurodegenerative problems, a lot of the mitochondrial related issues, a lot of the cancer related issues. A lot of this is coming from environmental toxins. That's why I have to screen this in everybody. If the patient shows up and they had a heart attack last year and they want to get healthy and not have another heart attack, you got to test their heavy metals. Because if they have a chronic source of inflammation and oxidative stress, it's going to damage their blood vessels. Same if they had breast cancer 5 years ago and they're better now, but they want to make sure it doesn't come back. You got to screen people for heavy metals regardless. And there's four big conditions, right? Mitochondrial or metabolic problems, cancer related issues, heart disease problems, and problems with your brain. They're all generated by inflammation and oxidative stress. So you got to, and on top of that, if you're doing a longevity based clinic, if you just say, hey, I want to work with healthy people and keep them healthy, then you got to improve mitochondrial function and reduce inflammation and oxidative stress because that's what keeps us vibrant and alive and healthy. So even for your wellness patients, or especially for your longevity and wellness patients, you got to do this test. And it's so important. And you're going to find these things and be able to fix them. This is not like, oh, it's a test to give somebody bad news and then they don't know what to do. You're going to tell them, hey, this is what's going on. We're going to get this stuff out of your body, out of your tissues. So then the symptoms from mercury, arsenic, lead, cadmium, aluminum, BPA, or whatever it is that you're looking at, whether it's an endocrine disruptor or it's a neurotoxin, are going to be similar, right? There's going to be weight gain, fatigue, depression, anxiety, all these different problems from all the different toxins, not just from mercury. So you can't tell from symptoms what's going on with the person. You have to be able to test this. And there are slight variations in the treatments for like aluminum versus lead or mercury. So you need to know what the metals are that they have, what the levels are, so that when you do the treatment, you can see if it works or not. You need a baseline test to see what the levels are. You need to do a treatment and you need to retest and make sure that everything is gone. Everything is gone. Uh, I like to think in terms of systems. I think that's a healthy and easy way and a practical way to explain this to patients. And so when we talk about, okay, yeah, heavy metals, mercury, lead, arsenic, cadmium, all those cause inflammation and oxidative stress and mitochondrial problems. Okay, how does that affect us on a systems-wide basis? Now we've got the nervous system, the GI, all these different systems that are involved. And whatever system of systems you like to use, I have my three systems that I like a lot, which is neuroendocrine, GI, and then detox as systems. In some of the longevity classes that I'm teaching now, we talk about the brain, the gut-brain connection, talk a lot about mitochondria, metabolic health, about immune health. So however many systems you want to have, just having some construct around that so you can explain how heavy metals are going to impact each of these systems. Or you can do it by condition. I like to do it that way too, meaning that you should be able to explain to a patient why or how heavy metals can cause neurodegenerative conditions like Alzheimer's and Parkinson's, and the mechanisms how heavy metal problems can cause damage to DNA and DNA adducts and abnormal replication of DNA, which leads to increased risk of cancer. Very clearly, how the oxidative stress from heavy metals damages mitochondrial enzymes and causes problems with mitochondria and metabolic health, and how the neurotoxins that we're worried about can get into and damage the brain. So you have either by condition or by body system a way to sit down with the patient and say, I know you're worried about Alzheimer's because you're Mom and dad both had problems with, their brains later in life. Let me talk to you about how heavy metals can impact and create neuroinflammation and damage nerve cells. And I think you should do this test for um, heavy metals, and let's look at your oxidative stress and your methylation process, at the same time, right? So having the ability to sit down with the patient and explain this clearly uh, to the non-chronically ill person who you're screening, because now we want you screening every single patient. So free radical damage and mitochondrial problems, this you can use as an approach for just about every patient because nobody wants their mitochondria damaged and a messed up metabolism, weight gain, I mean, it's fatigue, those kinds of things. So if you just explain heavy metal toxicity in relation to mitochondrial enzyme damage, you could probably get every single patient that you work with to do the test. There are, of course, a couple of different phases. We're going to focus on phase two, detox pathways, for today's talk, but let's not forget about phase one. And then, as a before we go on to phase two, just as a nod to phase one, is that phase one, the cytochrome P450 enzymes, they're located in membranes. So the enzyme itself is a protein made up of amino acids, and it's physically located in a membrane which is made up of fatty acids. So amino acids and fatty acids play a strong role in our detox capacity, as you can see just from this one example. So again, the cytochrome P450 enzymes, you have to make them, you have to produce them from your genes, instructing your body how to make this protein. And then that protein, that enzyme has to sit in a membrane. So if your cell membranes are screwed up, the system doesn't work very well. If membranes are screwed up, toxins can get into cells easily. They can't get out of cells very easily. And the things like the cytochrome P450 enzymes don't work very well because they're not well supported. Similarly, if you cannot make proteins very well, then you're not going to be able to make enough of these cytochrome P450 enzymes to keep things at bay. So protein synthesis and membrane repair and upkeep of your membranes are critical for detoxification. And they're not just like in the background kind of critical, they're like what's doing the job critical. They're literally what's doing the job. People don't think about that a lot. I don't know why. You should think about that. Okay, so cytochrome P450 enzymes embedded in the membrane, talked about that controlling movement in and out of the cells. That's one of the things that membranes do. But we're going to spend most of our time talking about phase two. And there's a lot to say about phase two. So we'll get into that in a second. And then SNPs. So you can also have genetic defects. And there's always the combination of your genes and how they're interacting with your environment and how much you've been exposed to these environmental toxins. And the people at highest risk obviously have high exposure to environmental toxins and poor genetic capacity to clear them. So today we're mostly talking about heavy metals. However, there are also organic solvents and biotoxins and industrial chemicals and herbicides and pesticides, and it's cumulative. If you have a problem clearing lead, mercury, and cadmium, it's most likely that there's some chemicals that are built up in your system as well. And much of the treatment that we do to clear one toxin is going to affect many of them. But it's what do they call it? Total body burden is the concept. And then again, on the conditions side, there are so many conditions that relate to heavy metals that you can't really tell from talking to the person. But there's some obvious ones like chemical sensitivity and autoimmune disorders and neurological problems. I mean, those people you have to test. But what I'm really trying to advocate for is that you're going to test the people that don't have obvious detox related conditions at all because many, if not most of them, are going to have metals that you want to clear out. And what's going to get better? It may be that their energy level gets better, their sex drive gets better, their skin gets better. There's going to be some level of improvement in people when these metals are cleared out because they cause a lot of damage. Okay, so now we're going to think about phase two. I'm really excited about phase two right now. I learned about this stuff 35 years ago, and then I've used it for 35 years, and now I'm like more excited about it than ever. So I made all these slides and as a way to kind of conceptualize it. So At the highest level, we just really need this one slide. I've got like 20 of them, okay, that I'm gonna skip through all these other ones just to show you the ones I'm gonna skip through because there's like one or two in here that really prove the whole point. And then the rest of this stuff here is filler for you. So to fill in your information. So the big picture concept is that in phase two, you got something bad. They just cleared phase one, and you got to cram something on there. You got to attach something. You got to conjugate it. You got to merge these things so you can get rid of the toxin. And then the question then is, what are the groups that attach to the toxins? Well, they're named based on what this pathway is. So in glucuronidation or glutathione conjugation, sulfation, methylation, acetylation, or amino acid conjugation, the name kind of gives away what's being glommed onto the toxin. So in glucuronidation, it's a glucuronic acid molecule. In glutathione conjugation, you already probably guessed, it's glutathione that's grabbing that thing, binding it up. In sulfation, it's a sulfate group. In methylation, it's a methyl group. In acetylation, it's an acetyl group. And in amino acid conjugation, it's mostly glycine and taurine and a little bit of glutamine. So what's important here then is the group that you're attaching to the toxin to get it out. You got to have enough of these things or it's not going to work. You got to have enough glucuronic acid. How do we supplement that? It's called calcium D-glucarate. You got to have enough glutathione, enough sulfur compounds. That could be anything from MSM to methionine, however you're getting sulfur into the person. You got to have enough methyl groups, so they have to be able to methylate well. And you have to have enough acetyl groups. Acetyl groups are super important. They think about like acetyl-CoA. That's like the most important thing in your whole body is acetyl-CoA for energy production. So that's pretty important. And then the amino acids like glycine and taurine. So that's the stuff that you're using to run phase two and these individual items, whether it's a methyl group or a glutathione molecule, are attaching themselves to the toxin. And if you don't have enough of these things on the right side, then environmental toxins are going to build up. And here, these slides are the super big detail on each of those topics if you want to look at them later. And I got as much detail in here as I could give you, for a slide at least. And then here, this is a bird's eye view of what phase two is really doing, what's happening. And I thought it'd be nice to look at it by like percentage. So 70% of your phase two is glucuronidation. So right away, that lets you know, oh, glucuronidation is pretty important. So if you're running, as you are all running a GI 360 stool test on everybody, and you see high beta glucuronidase, bam, you know right away glucuronidation isn't working well. You know that from the stool test. And then look, the implication for phase two is pretty severe. It means 70% of the stuff you're supposed to be clearing is just 70% of the capacity of phase two is not going to work. So glucuronidation is really important just because there's a lot of it happening. However, not to undermine like methylation, which you're also all testing for, hopefully, methylation defects are super important just because of its role in the whole overall system, right? So it's kind of, if you look at it as a volume, glucuronidation stands out, but then you can also look at, okay, what are these individual pathways getting rid of? And that's the other way to look at it. So if you're focused on hormones and the person, let's say that you run a HUMAP and you see that their hormone metabolites are really screwed up and you want them to metabolize hormones better, of course, you're going to use calcium D-glucarate. That's kind of standard. But then you're also going to want to think about sulfur amino acids because that's another pathway by which we clear hormones. Heavy metals, glutathione would come to mind first. You probably wouldn't think about calcium D-glucarate and heavy metals, nor should you. You should be thinking about glutathione and its role in heavy metal detoxification. So ultimately, when you're treating liver detox pathways, you want to know where's the input coming from? What's the bad thing? Is it bad beta glucuronidase, or is it bad mercury, or is it some estrogen metabolites you want to clear? And then you can customize a phase two program to support all of the phases, all six of them, and then emphasize whatever phase is extra important. So I usually use combination supplement products that include support for all the different six phases. And it's not that hard, right? It's amino acids and B vitamins and a bunch of magnesium and some minerals. So not too hard to do that. And then if you really want to hone in on methylation, You would give more methylation support. Or you really want to hone in on getting rid of heavy metals, you can give more glutathione support. But you're always treating the whole liver, right? It's not like you can just get rid of mercury and leave every other toxin unattended to. We want to think about the bigger picture. And so again, here's a bunch of slides that I put together just to kind of reemphasize these phases, the 6 different, phases, stage 2 phases. Glucuronidation, and you kind of got to memorize these. You got to know these: glucuronidation, glutathione conjugation, sulfation, methylation, amino acid conjugation, and acetylation. And if you don't know what acetyl CoA is or does, you got to look that up and figure that out. Okay, that's pretty important. And of course, you should read about glycine and taurine and what they do and why they're important for your gallbladder as well as for your detox pathways. Methylation, we all need to know about. Sulfation, it's so important. So important for brain programs, so important for detoxification. The sulfur amino acids, you need to memorize methionine, cysteine, etc. And then glutathione, you should know a lot about, and glucuronidation. But in the short term, as you're studying all this stuff, you can use combination products that all the companies we work with have to hit all these different pathways at the same time, and then emphasize individual areas of detoxification that you want to focus on. Okay, whether it's hormones and you're doing methylation, or it's metals and you're doing glutathione. Okay, so just a minute on methylation and glutathione because they're connected in a deep way. So oxidative stress, you can see at the top of here, when you have a lot of oxidative stress, your body is going to decrease methylation because it's increasing glutathione production. So when we have a lot of oxidative stress, we make more glutathione. And these pathways are intimately connected. So as your glutathione production ramps up because of the oxidative stress from the heavy metals, your methylation decreases. And we just saw methylation is one of the detox pathways, one of the many, right? One of the 6. So glutathione support ends up being a central component to methylating properly and to clearing metals. And it says right here in the diagram, cysteine or N-acetylcysteine, glycine, these are the nutrients that we can use either along with or separate from or in addition to glutathione itself. But usually, most of the time, I think, I don't know if it's preferred, but it's nice to use N-acetylcysteine and glycine to boost glutathione. And if you have a more severe case, to use glutathione in addition on top of that. That one's not so important for now. Methylation, I think you guys have all studied methylation. You should have some grip on that. So we'll skip through some of those. Oh, this one I want to mention though, because this is just such a cool idea, is that when you're thinking about methylation, this could be related to clearance of estrogens or clearance of whatever you're trying to get rid of in your liver. Creatine, you don't really think of creatine as being a detox product, but half of what we're methylating is devoted to creatine production. So you can actually take 5 grams of creatine a day as a way to indirectly support your methylation. And then the other 20-30% of what we're methylating is to make membranes. So anyways, creatine is kind of a sneaky way to support people if you're looking for something like that. And then we're going to have plenty of time for questions because I think the questions that came in already were really good and want to cover that because it's going to be more on the practical side. So I'm going to talk just briefly about amino acids and protein synthesis. So you have to have amino acids for a whole variety of reasons if you're going to effectively clear heavy metals. You need to be able to make albumin and metallothionein. Those are made from amino acids, and they're the ones that are binding heavy metals. The detox enzymes that we're talking about are all proteins. So you have to have amino acids to make those. You need amino acids specifically for that one pathway I just showed you. Amino acid conjugation relies upon glycine and taurine. You have to have arginine and citrulline to clear ammonia. You need cysteine and methionine for the sulfur, compounds. So you need a lot of amino acids in order to clear environmental toxins. You also need 20 amino acids to build proteins. And so there's so many reasons why you need amino acids with detoxification. You just got to always give people amino acids. And The testing will show you exactly which ones and how much. But you need to have adequate amounts of all 20 amino acids to build proteins. You need certain amino acids for methylation. You need certain amino acids to make glutathione, right? It's cysteine, glycine, and glutamine. So amino acids just show up over and over and over again when you're thinking about how you're going to build proteins and how you're going to run detox pathways. It ends up being, I don't think you could do a detox program without amino acids in it. Here's the ones for glutathione production, etc. Glycine, and so these you have to memorize, right? Glycine, cysteine, and glutamine are the three amino acids from which you make glutathione. And then amino acids and methylation, there's 5 amino acids. And I don't know about you, but I need my glasses just to see this. They're kind of buried in here in the single carbon pool part of the slide. Serine, glycine, histidine, glutamine, and tryptophan. Those 5 amino acids contribute the carbons to the single carbon pool, which is what you're using in your methylation processes. So you have to have amino acids for that too, those 5. Anyways, if you're worried about this, and you should be a little bit, you can just give free form amino acids to everyone who you're doing a detox program with. And then you can add extra amino acids. Like, for example, if their sulfation pathway is not working well, you can put in methionine and stuff like that to get more specific on it. So we talked about that, talked about that. And then here, a couple of things like heavy metal chemical exposure, uh, environmental toxin exposure, and internal toxin exposure kind of all end up getting lumped together. So let's say you have a mercury, lead, arsenic problem to begin with, and your liver's not clearing things very well. It can easily spill over to creating problems with other toxins that your body's trying to clear. And so you have to think a little bit globally when you're dealing with these kinds of issues. So I just want to mention one or two things that no one ever thinks about, just so they're on the top of your mind. And the most important one, I think, is at the top of this slide, which is ammonia clearance. So we use arginine to clear ammonia, and some people don't clear ammonia very well. So just keep that in the back of your mind, the ammonia toxic people out there. We also use arginine to make nitric oxide, so it's pretty important for a variety of reasons. But you can have internally generated toxins as well that are problematic from things like clearing ammonia improperly, or from your gut, dumping a ton of toxins onto the system in general. All right, just a reminder for those that joined us late, we have a Doctor's Data GI Masterclass that we're offering for half off for you. They're taking this class. And we have a ton of other coursework coming up too. You can check out the Kalish Institute website for all that. Now, I went through the slides pretty quickly because I know the questions that came in already are going to be super important to cover. And I wanted to jump right into questions. We have tons of time. We have a half an hour for questions. So let's get to it, okay?